In this question, we're asked to decide whether two elements will form an ionic compound, determine the empirical formula, and then name the compound. So there's kind of a lot of work to do. So first, we have sulfur and lithium. In order for an ionic compound to form, we need a metal and a nonmetal. So if we look here, lithium is a metal, sulfur is a nonmetal, so we can form an ionic compound. We also need to find their charges. Since lithium is in group 1a, its charge is +1. Sulfur is in group 6a, so its charge is -2. Remember that lithium wants to be +1, so it'll lose an electron and be like helium, a noble gas, and sulfur wants to gain 2 electrons, so it'll be like argon, a noble gas. So that is what's going on. So we have Li plus interacting with S2-. Cross the charges, and we find that the formula of this compound is Li2S. Next, we need to actually name this compound. Before I do that, though, I should put the yes an ionic compound will form, because that's the formula that we just drew. So now I need to name this ionic compound. So this is the flowchart for naming different types of compounds. Again, in ALEX, a lot of times the questions are broken up, so these are all ionic compounds, there's no covalent compounds. But on an exam or something like that, it's important that we have this flowchart in our minds. So it says, does the compound contain a metal or a polyatomic ion? It contains lithium. So the answer is yes, it's ionic. Is the metal capable of forming multiple charges? And this is generally the transition metals, or the metals under the nonmetals on the periodic table. Well, lithium is here on the periodic table, so therefore it is not capable of forming multiple charges. Said another way, it's a main group metal, so we don't need to worry about adding a Roman numeral. We just name the metal, lithium, and then the nonmetal adding an "-ide", ending in "-ide". So sulfide. So we have lithium sulfide. Next one, lithium and chlorine. Lithium is still +1. Chlorine is 1 over from sulfur, so it only needs to gain 1 electron to be like argon. Said another way, elements in group 7a form charges of -1 in ionic compounds. So we get Cl-, cross them, and we get LiCl. Since lithium is not a transition element or an element capable of forming multiple charges, we're going to call it lithium chloride, and we're not going to use the Roman numeral as it says in the flowchart. Next, we have barium and sulphur. Well, we've already used sulfur, so sulfur is 2-. Let's find barium on the periodic table. Barium's in 2a, so it's going to form +2 charges. So it can lose 2 electrons to be like its nearest noble gas. So it's going to be Ba, 2+, cross them, and we get Ba2S2. But these are the same number, so they have a lowest common denominator, which is of course 2, because they're both 2. So it's BaS is the simplest form, and this is the empirical formula of the compound. So we now need to name this. Well, barium is a main group element. It's in 2a, so we just call this barium sulfide. So the nonmetal ends in "-ide" as in the previous cases. And then finally it says strontium and lithium. Well, strontium is a metal, and lithium is a metal. You're not going to form an ionic compound between two metals. You need a metal and a nonmetal. Said another way, you need something to donate electrons, the metal, and something to accept those electrons, the nonmetal. Two metals will not do that, so the answer here is no. And I just realized I forgot to answer yes to these two questions, because we were able to form ionic compounds. Not only did we form them, we wrote their empirical formulas and wrote their names.